Streams can help us handle large amounts of data in a fast and efficient way because they operate on a single chunk of data at a time, instead of reading all of the data into memory at once. In this tutorial, we'll define the concept of a stream in Node.js. We'll talk about the limitations of reading a large file into memory and how streams can help us get around those limitations. We'll list some of the benefits and use cases for using streams in your programming. And we'll talk about how to connect streams together in order to move data from a source to a destination. A stream is a collection of data which arrives piece by piece. The data isn't available to us all at once, and instead we work on it piece by piece. In Node.js, streams are used by many of the built-in modules to handle asynchronous data processing. For example, the built-in HTTP module uses streaming interfaces within the client request and server response objects, which are at the heart of the HTTP module. Streams also help us buffer data. It collects the data as it comes in until we're ready to use it or until all the data has arrived from the stream. There are several benefits that streams bring to Node.js which make them very important. First is that streams are memory efficient. That's because with streams, we only ever work with chunks of data at a time, and not all of the data that the stream represents. Node.js processes have a maximum memory limit of just under 2 gigabytes. So if you wanted to read a 20 gigabyte file into memory, you would quickly run out of memory and the process would crash. But with streams, we don't need to read the entire file into memory. Instead, we can handle chunks of the file in order to get around hitting the maximum memory limit. It's this approach that makes streams memory efficient as opposed to buffering all of the data in memory at the same time. Streams are also able to begin handling data as soon as the first piece of it arrives. This means that streams are also time efficient. In the example of opening a 20 gigabyte file, you would need to wait until all of the data had been loaded before you could even start working with that data. But with streams, you're able to start working with that data as soon as the first chunk arrives, and then you'll be able to work on the next chunk as soon as that piece is made available. Finally, streams are also composable, meaning that they can be connected to and combined with other streams. The output of one stream can be used as the input for another stream, allowing us to combine streams into a pipeline through which data can flow between the various streams. There are 4 main types of streams in Node.js. The first type is a readable stream, which represents a source of input. You read data from a readable stream. Writable streams represent a destination you write data to. Writable streams are sometimes referred to as a sink because it is the end destination for streaming data. It differs from a readable stream in that you can't consume data from a writable stream, you only push data to a writable stream. Things get a little bit more complicated when we get to duplex streams. A duplex stream implements both a readable and writable interface. Duplex streams can both receive data as well as produce data. An example would be something like a TCP socket, where data can flow in both directions. You can receive data from an open TCP connection as well as write data to the other end of the TCP connection. A transform stream is a type of a duplex stream where the data passing through the stream is altered. The output will be different from the input in some way. You can write data to a transform stream and also read data from it after the data has been transformed. The final type of stream is a pass-through stream. Pass-throughs are a special type of transform stream which do not alter the data passing through it. According to the Node.js documentation, these are mostly used for testing and examples. They serve little actual purpose beyond just passing the data along without altering it in any way. All streams are instances of event emitter. Event emitter objects in Node.js are used to emit and respond to events asynchronously. As such, streams emit events of their own which can be used to read and write data, manage the stream state, as well as handle errors. While it's important to understand some of the events that streams can produce to be able to understand what's happening at their low levels, listening to events is not the recommended way to consume streams anymore. Over the years, the Node.js Streams API has changed quite a bit. And these days, the recommended way to consume and interact with streams is by using the pipe and pipeline methods, which will consume the streams and handle their underlying events for you. We'll cover the pipe and pipeline methods next in the tutorial, but we want to point out the important fact that all streams emit events, and at their heart, streams are just basically event emitters. So if a stream's events aren't the best way to interact with it these days, why do we even mention it? Well, there are some cases where you want a very fine-grained control over how a stream is consumed or how it works. Stream events can be really handy for that if you want to, say, run custom code when a stream ends or begins, or when something within the lifecycle of the stream happens. You can read the Node.js stream docs for more in-depth information about the stream events, but we're going to talk briefly about some of the most important ones to understand. Readable streams will emit a data event whenever a chunk of data is received. If you create a handler for the data event, the chunk of data received will be passed to that handler. The readable event will be emitted when there is data ready to be read from a readable stream. This is different from the data event in that readable signifies that the stream is ready to be consumed. Attaching a handler to this event will actually kickstart reading the data from the stream. It's not strictly required to listen to this event in order to start reading from a readable stream, but attaching a handler to this event has the side effect that it will start the flow of data from the readable stream. Readable streams will fire an end event to signify that there is no more data available to be read from the stream. This event is fired by a readable stream to let you know that there's no more data that's going to be coming from the stream. Error events fire when an error has occurred within the stream. An error object will be passed to your handler if you're listening to this event. Writable streams fire a drain event to let you know that the internal buffer of the writable stream has been cleared and it's ready to receive more data into its internal buffer. The finish event is fired by writable streams when all data has been written to the underlying system. That means that the writable stream has finished processing whatever data it has been pushed. Writable streams also fire an error event, similar to readable streams. It represents an error occurring within the writable stream and will also pass you an error object to the handler. Now let's talk about how to consume data from streams. Streams with a readable interface have a pipe method which allows you to connect streams together. Piping is the main way that we consume streams. Under the hood, the pipe method uses the events emitted by streams, abstracting away the need to handle most of those events. Piping allows us to send data from a readable interface into a writable interface. The pipe method is available on readable, duplex, and transform streams. Pipe accepts a writable stream that the data from the readable stream will be sent to. This is a very trivial example of piping two streams together. In this example, we're using process.standardin, which is a readable stream that represents input sent to your program from the command line. We're piping that input to process.standardout, which is a stream that implements a writable interface that writes to standard out of your program. In this case, that output will be written directly to the command line. When we run this file with node index.js, the process will listen for input to standardin from the command line, and then write that input into process.standardout, which will then print that input back to the command line. Hit Ctrl-C to end the process when you're done. Calling pipe returns the destination stream, which allows us to chain another pipe onto the stream if the destination stream also implements a readable interface. This example uses a pass-through stream to show how we can chain multiple streams together using pipe. We're piping the input from process.standardin into the pass-through stream, and then from the pass-through stream, we're piping it into process.standardout. We're able to do this because pass-through streams implement both a readable and writable interface. Like we said before, pass-through streams are mostly for demonstration purposes and don't actually do anything to the data passing through them. So if you run this example again, it'll behave exactly the same way as it did before. The FS module has special helper functions to help us create read and write streams from files. These methods allow us to either read data from a file as a stream or write data to a file as a stream. The use case we mentioned at the very beginning of this tutorial, processing files too large to fit into memory, relies on these methods. In this example, we use fs.createWriteStream to create a stream which writes data from standardin directly to a file called file.txt. We can run this example and start typing some input into the command line. We use Ctrl-C again to end the process. If we go and take a look at file.txt, we'll see that what we typed into the console was written to the file. Once you have some text in file.txt, we can invert this. We can create a read stream from file.txt and then pipe the data to standardout to display it on the command line. Another option to connect streams is to use the new method available in the stream module called pipeline. The pipeline method was added in Node.js version 10, and it is an improvement over the regular pipe method. It's still important to understand the basic pipe method because you'll see it used pretty often, but I definitely recommend that you use the new pipeline method whenever possible. In this example, we'll use the pipeline method to pipe data from a file called file.txt into another file called out.txt. At the top of the file, we've required the pipeline method from the stream module. And on line 10, we're passing in the streams that we're piping between. Pipeline takes any number of streams as arguments to pipe between, with the last argument being a callback function. If an error is emitted from any of the streams in the pipeline, this callback will be invoked with the error object that was emitted. The callback will also run once the pipeline has successfully completed. Using pipeline simplifies error handling and stream cleanup, and also makes combining streams in complex ways more straightforward. When an error occurs when using pipeline, the streams will be destroyed. Destroying the streams releases their internal resources, freeing up any memory that the stream might have been using. This cleanup step of destroying streams is useful for preventing memory leaks, which can occur when a stream has ended but not released the resources that it was using. When using the basic pipe method, you're responsible for destroying streams yourself when things go wrong, so one of the main reasons to use pipeline as opposed to pipe is to make sure that streams are automatically cleaned up when errors occur. The examples that we've shown so far have been fairly trivial, meant mostly to demonstrate how you work with streams. Now we're going to show a more powerful use case, using transform streams to alter the data that is streamed from the source to a destination. Transform streams are a useful way for helping us create a pipeline to alter or process streaming data. In this example, we're going to create a transform stream which converts all strings that pass through it to uppercase. To create our transform stream, we're using the transform constructor from the stream module. We're required to implement a method called transform on our transform stream. This method will receive a chunk of data that's passed to the transform stream, the encoding of the chunk, and a callback function which we can use to return an error or the newly transformed data. We convert the chunk to a string because by default the data chunk will be a buffer object, and then we're going to call the string method to uppercase to convert the string to uppercase. We output the transformed chunk as readable data by passing it as the second argument to the callback. This data will then be able to be read by the stream that our transform stream is being piped into. Now we'll create a pipeline that streams data from process.standardin into our uppercase transform and then back out to our process.standardout. Now we can run this file, type something into the command line, hit enter, and see the text echoed back to us in all uppercase. Exit the program by hitting Ctrl-C. There you go. That's how you create a basic transform stream to help you process data in a streaming pipeline. To recap, we defined a stream as a collection of data that arrives one chunk at a time and doesn't have to fit entirely into memory. We talked about how the size of files you can load into memory are limited by Node.js's memory cap, and that streams can help us get around that memory cap by working on data one piece at a time. We discussed the benefits of streams being that they are both time and memory efficient, and that a large part of their usefulness comes from the fact that they are composable. We also talked about how to connect streams together using pipe and the new pipeline method.